So we'll go over the answers to the quiz you guys just took. Of course, I won't be able to get this graded before your test, obviously. I mean, we don't. Your next class is the test, right? So, but I want to make sure that we understand how to solve these problems. So I'm going to go over the solution with you right here as soon as this thing warms up. I can't remember. Can I turn off half the lights in here? No, but I can turn off all the lights. Do not go to sleep. I hope that's okay. Okay, so to start with, solve, minus 7/3 x plus 1/3 equals to minus 9. So once I'm done with class and I've gotten the solutions from the two students who are taking it by Zoom, then I'll post the solution. Okay, I'm just waiting on them. But once I have that, then I can post a solution. And you'll have the solution to this. You'll also have the solution to the quiz from the Tuesday, Thursday class. So you have both of those to look at and kind of give you, some kind of sense of where tested 1 is going to be, right? Remember, the material that I covered last class is not on test 1, right? Systems of equations, that's a test 2 topic, just to be clear, all right? So the first thing I do is I multiply by 3, right? Because that will get rid of the third. And so we multiply by 3, we distribute. 3 cancels 3, 3 cancels 3. That leaves us minus 7x plus 1 equals to minus 27. Can you guys tell me how I get from this line to that line? What did I do? I did two things. I added 27 to both sides, and I added 7x to both sides. And so when I do that, effectively I move. Another way to think about it, right, is if you move a minus 7 from the left-hand side to the right-hand side, it makes it a plus 7, right? And if we move a minus 27 from the right-hand side to the left-hand side, it makes it a plus 27. So 27 plus 1 is 28, of course. And so there we go. X equals 28 over 7. And I think that's 4, right? Like, teacher, I left it as 24 over 7, 28 over 7. Are you going to take off a point? I mean, no, right? I mean, 28 over 7 is a perfectly fine answer, but, certainly x equals to 4 is the more tasteful answer, right? I mean, it's... I would like you to simplify reasonably uncomplicated fractions like that when you can, because most people want you to, so I probably should too, so I can be a conformist, Let's see here. Problem 2. Here we have 2x, 2 times quantity x plus 4. And if you have a question about anything, as I'm going along, just jump in. I can turn on the lights and write stuff over here, okay? So distribute the 2. I get 2x plus 8, right, equals to 6x. And so subtract 2x to the other side. I get 8 equals 6x minus 2x, which of course is 4x. And then I divide both sides by 4. That gives me x equals to 8 over 4, which is 2, right? X equals to 2. Have I written enough work? At the level of this class, maybe my solution's a little bit too short, right? I mean, I probably should have another line between here and here. It would improve my solution. I do need you to write down work, right? Don't just write answers down for me. That makes my life difficult, whether you're right or wrong, right? Because if you're right, I feel like I should take off points because you didn't show work. And if you're wrong, you've given me no way to give you partial credit, right? So do write down your work. The other thing I should say is, these kind of problems, what should you do before you go on? Check your answer. Okay, so let's try it out. Put in 2. What's 2 plus 4? 6. 6 times 2? 12. What is 6 times 2? So it works, right? It's not a big deal to plug these answers back into the equation and see that they work. I mean, admittedly, the one with fractions up here is a little bit more annoying. To check that that one works, we still have to think through the fraction, right? But if you think about plugging 4 up into here, we get minus 28, 7 times 4, which is 28, minus 28 over 3, plus 1 over 3, which is minus 27 over 3. What's minus 27 over 3? Well, it's minus 9. So that one also checks. So, and of course, you guys have a calculator, so you can check with the calculator as well. I don't think you need a calculator for this test, but I say that on the basis that you have solid proficiency with arithmetic. If you know that you don't, you need to double check yourself with a calculator, right? So, some of us have had, teachers who didn't force us to learn all of the multiplication tables carefully, and so you're kind of stuck, right? You got to do something to make up for that. So a calculator can help you. All right, so this one is an absolute value question. I am sure, without even looking at the papers you guys just turned in, that if I go through the stack, probably half of you have given me just one of these answers. Right? You don't have to raise your hand, but I'm sure there's someone here who did. What we need to remember when we have absolute value is we have to allow for the plus and the minus, right? So an absolute value equation should have like 2 answers, usually. And so I set 2x minus 1 equal to minus 2, or I set 2x minus 1 equal to 2. These are the 2 choices, right? And then I solve each one as we usually do. Add 1 to both sides. So I get 2x equals minus 1, and I get 2x equals to 3 over here. Divide by 2, I get x equals minus 1/2, or x equals to 3/2. And again, we can check our answer, right? What happens when you plug in minus 1/2 up into the absolute value of 2x minus 1? What happens if we plug minus 1/2 up in here? We get, what's 2 times minus 1/2? 2 times minus 1/2 is minus 1, right? So I get minus 1, so I get the absolute value of minus 2 when I plug that in. The absolute value of minus 2 is 2, right? So this one works. And if you plug 3/2 in, you get 3/2 times 2, which is 3. 3 minus 1 is 2. Absolute value of 2 is 2. So plugging this in also works, right? You can check your answers. Any questions? Okay. So if I was you, and I got that wrong just now, on my formula sheet I would make myself a reminder, problem with absolute value should have 2 answers, right? What's the one way that can the only way that might not be true is if you somehow have these 2 different cases conspire to give you the same answer. That could happen. Or it's also possible to have, well, I'm trying to think if it's possible to have no answer at all. It is. Could you guys tell me what I could put here to have no answer? How could I make it so there's no solution at all? What could make this equation false? What do we know about absolute value? What is it? It can't be negative, right? So if I, for example, put absolute value of 2x minus 1 equals to minus 7, game over. We can't solve that. There's no solution because you can't have absolute value equal to something negative. So yes, there are absolute value equations which have no solutions. There are absolute value equations which have one solution that's kind of like the same thing repeated. But more often than not, the problem I would give you would be one like this, where we have 2 distinct answers as our solution to the absolute value problem. Moving on here. Problem 4, the dreaded interval notation. So I personally, if I'm not sure, I draw a number line. And once I draw the number line and picture 1 and think about where x has to be in relation to 1, that tells me, oh, this is the interval from minus infinity to 1. And 1 is included because we have less than or equal to, right? If that was instead of less than or equal to, if that was just less than, that would make this a curvy bracket instead of a square one. And what's that? Oops. But you did the number line instead of that? Oh, this? Oh, did you write minus infinity to 1?
Yeah, I didn't write it.
oh no, you don't have to write all this. This is how I think about it. That's not really, like, I say show your work, right? But this is an example of a question where there's really no work to show. So I write this down because for the people who don't understand that this is the answer, it might be the case that that number line helps them see why this is the answer. But no, you get full credit just for that. Like that's copacetic. Look here. So is 2, 2 on the graph of y equals 5x minus 8? Well, plug it in and see what happens, right? Plug in 2. 5 times 2 is 10. 10 minus 8 is 2. So, yep. We plug it into the equation holds true. It's on the graph. I think if you look at the quiz I gave to the other section, they had a point which was not on the graph. So you can see what that looks like, if I remember right. Probably some of you didn't know what I meant by dimensions. Am I right? Sorry about that. But to be fair to the other section, I didn't tell you. So they were also confused about that. But dimensions just means length by width, right? So you're like, yeah, sure. Absolutely. So, you know, like if you go to the furniture store and something, you want to buy a kitchen table, you might want like a 30-inch by 60-inch table or something, right? Those are the dimensions of the table. Or the window, you might want a 20-inch by 40-inch window. That's the dimensions of the window. So when I ask for like dimensions of a field, I'm asking for the length and the width kind of as like a pair. Of course, if you multiply the dimensions for a rectangle, you get what? The what? The area, right? So, I mean, that would have also been an interesting question to ask here. What's the area of the field? Right? To find the area, we would have multiplied the length and the width we calculate here. So for me, the first thing I do is draw a picture. And I choose a variable. I called it W because I'm told that the length is 46 feet longer than the width, right? 48 feet longer than the width. So that means that L is W plus 48. And once I do that, well, then I can figure out the perimeter because it's this length plus that length plus that length plus that length, right? I mean, it's just, and so that works out to 4W plus 96. Subtract 96 to the other side, that leaves you 120. But 120 divided by 4 is 30, so the width is 30. And that means that the length is 30 plus 48, which is 78. So the dimensions are 78 by 30. Yep.
So we had.
So I will give significant.
So next time you ask for that, you want us to write it like that, like L by W equals the little hash mark.
Well, these are just. This is just feet. That's just like a shorthand for foot. But I mean, it's not. If this was a physics class, and you didn't put units on the answer, I'd bleed you like a pig. I mean, I would take all your points, because us physics people, like, we're almost like we have like a religious attachment to units on answers, you know. But this is a math class, so like I'm pretty chill about it. I don't care. Yeah, if you have set 30 and 78, I'll give you full credit. Yep. Because, you know, I was not trying to like penalize you guys for not knowing what dimensions means. It's just, maybe on the test, maybe if I ask this question, I'll ask for the area instead. And then there shouldn't be any ambiguity if I ask for the area, right? If I said find the area of the rectangle, you guys would be fine? Okay. I try to be sensitive to this issue because this is a really big problem in lower level math. Is we tend to teach math with this like more of a focus on how you present the answer as opposed to the understanding of the answer too much, to the point that people give too much, what's the word, too much of the importance to the format of the answer as opposed to the spirit of the answer. And so like my brother, for example, there was a homeschooling mom where we were growing up, and I think Bill was already like a math major at this point. My brother's a math professor, but anyway, this homeschooling mom was like, my daughter is really bad at math. She gets all the answers wrong. And my mom's like, well, my son's good at math. He can look at it for you. And so Bill goes over there and he looks. And I mean, sure enough, her answers don't match the answer key, right? But 95% of them are correct. They're just a different format of the answer. And see, so the mom didn't have enough of an understanding of math to understand that that student was not wrong. They were just not adhering to the particular format of that answer key. That's a big problem we have with teachers. If we have teachers who don't understand when two correct answers are equivalent, they may teach students that are wrong who are actually right. That's a very bad thing. So I try very hard to avoid that. So like if you give me an answer that is the same but in a different format, I almost always will count it correct. Because that's a big issue to me. Anyway, so the next one, what do we do? 19 minus t greater than 5. So what I'm going to do is I'm going to subtract 5 from both sides, and I'm going to add t to both sides. Because I don't like minuses, you know? So add t to both sides, subtract 5 from both sides. That gives me 14 greater than or equal to t, which we could rewrite as t less than or equal to 14. Whoa. Anyway. Yeah, think about that. Every time I've been looking for a house lately, so like, if you read like, real estate descriptions of houses in Livingston, and they talk about like, quaint small town atmosphere, they never have a line about like endless sound of truck noise in your front yard. Listen to the J brakes. Let's hear. So there you go. Any questions about this one? I think a lot of you probably got this one right. If you didn't get it right, I think you can get it right if I ask the similar kind of question on the test, right? Now this one here, be careful. Notice that it's greater than or equal to, right? So when it's greater than or equal to, we have to split into two cases. The one is less than or equal to minus 12. The other one is greater than or equal to 12. If this problem had less than or equal to instead of greater than or equal to, it would be a very different problem. You should have both of these things on your formula sheet. You need to understand the difference between absolute value less than kind of problem versus absolute value greater than kind of problem. They're different.
Can you explain the difference again?
Sure. So let's look at this one for a second. So when it's greater than or equal to, that means, so let me turn the lights on here for a second. So the basic issue is this. I'm trying to write on a whiteboard without a whiteboard marker. That's a more basic issue. Let me illustrate the problem, the difference with the number line. So if I have, for example, the problem, absolute value of x less than, say, 6. So absolute value of x, what is that? That's the distance that x is from the origin. So if I draw 0 here, that means that you're within 6 units of the origin. So you can go out 6 or you can go back 6, right? And so your x is like somewhere in here. So you could write minus 6 less than x less than 6. That would be how to understand that kind of absolute value inequality. In contrast, right, how would the same thing play out if we had absolute value of x greater than 6? Well, think about what that means geometrically. So we have 0, we have 6, we have minus 6, right? Where is x? See, in terms of distance, this means that the distance of x from the origin is larger than 6. That means x is either out here, or x could be out here. So we have two different cases. We either have x like is less than minus 6, or x is greater than 6. So see, there's a fundamental difference between solving a greater than an absolute value versus a less than an absolute value. Less than absolute value we can recapture as a compound. This is called a compound inequality, right? compound is when you can take two inequalities and put them together like that. This, on the other hand, we can't write as a compound inequality. These x's are logically distinct cases. All right, it's not the same x. So this problem on the quiz was greater than, so I had to break it up into two cases. And in so doing, we found, oh man, oh, I thought they were happy. But I'll try to behave. So we either had this case or that case, right? Yep.
How do you get negative infinity?
Well, y is less than minus 7/8, so it just somewhere beyond minus 7/8. So
So if it's less than negative, it would be negative infinity?
right, or even if it's just less than 1. If like y was less than or equal to 1, it would be like minus infinity all the way up to 1. It's not about the number being negative. It's about the variable being to the left of a bound. Like that. So I know we're just about out of time here. Let me just go on here. The domain, so we need 5x plus 3 not equal to 0. So that means 5x not equal to minus 3, which means x is not equal to minus 3/5. So this is a perfectly fine answer. Probably some of you wrote x equals to minus 3/5, right? I'm not going to take point off, but I really would rather you didn't write that, because that's the opposite of what you actually want, right? You want everything except for that value. So that should be stated in your solution, right? The example I gave to the other section was like, you tell your little brother, don't touch me, and what does he do? He touches you. That's kind of what this answer is if you put equals. So if you've got a little brother, it's annoying. You understand that. Let's see here. This one, no, they're not parallel. They're not perpendicular. If you rewrite them in slope-intercept form, you can see slope 8. You can see slope 7. They're neither equal nor negative reciprocals. They're not parallel. They're not perpendicular. They're just skew. Finally, this one, the domain, we go minus 8 all the way over to, we got to exclude the 4, and then we go from 4 to 8. So minus 8 to 4, union of 4 to 8. If you threw 4 into the domain, don't feel bad. I did that in my solution 2 in the other section, which was bad. The range, the y values go from minus 6 all the way up to 6. Minus 6 is not included, but 6 is. That's why the square bracket, where's the open bracket? F of 4 is undefined because that's where a hole in the graph is. F of 2 is 6 because of that point right there. And the line looks like this. So minus 3, minus 6 is there. 6, 8 is there. The slope, it turns out, is 14 over 9. I use the 0.68 to write down this point slope formula. If you write that as your answer, or if you use the other point as an answer, I'll count it right. It's fine. If you simplify that, you get 14/9 x minus 4/3. So anyway, sorry I had to rush a little bit. I blame the Zoom. The Zoom ate 10 minutes of my time today, so sorry about that. I'll see you guys at the test. Yep. Number 10? Yeah, I will post this in course content here. I'm going to hit the stop record so you guys can